Good evening, everyone. Good evening, all. Are you all able to hear me? So I think let us start the session. I hope you are able to hear me, and if you have, if you are facing any kind of technical glitches or some problem, please let me know. Either you can unmute yourself and tell, otherwise you can chat. And if there is any problem with the Google Meet, again just rejoin the meet. That's all. And yeah, so let's start the session. So this is the live session for Basic Linear Algebra course, NPTEL. So what we will be doing here is, we will just discuss the previous content. That is, whatever has taught in the last week, we will just revise. We will not go through all the proofs and all. We will just revise the concept, and then we will solve some problems. So that problems will be similar to the assignment problems that you have to submit. So you just go through the problem and you can solve some other problems, so that it will help you in the solving the assignment problems. So in this session, if you have any doubt in between, you can just ask. If you are not talking, always please mute, and if you have any doubt, unmute and ask the questions. So I think there are enough people now, and let us start the session. So before starting, let me introduce myself. I am Harsha. I am a research scholar from Indian Institute of Technology, Tirupati. So I will be taking the class every Tuesday for the next 8 weeks. That means each week one session. That is a 2-hour session, mainly for the problem solving. So let me share the screen first. Can you see my screen? Is the screen visible for everyone? Okay, thank you. Okay, so we will start the session. So I hope all of you have gone through the week 1 lectures. So before the live session, just go through the lectures so that you will understand the concept. So it will help in solving the problem. So we can solve the problems together. So first of all, what exactly we are studying in linear algebra? Basically, we are dealing with the linear equations. There are actually many kind of equations. For example, x square plus y square equal to c square. So this is a very basic equation. What does this represent actually? Can anyone tell? What does this equation? This is an equation of
a circle.
Yeah, equation of a circle. Is this linear?
No, it's not linear. It has quadratic terms.
Yeah, it has quadratic term, that is square term is there. So this kind of equations are not linear. Okay, so what exactly linear means? It consisting of the terms with the power 1. So if we have a variable x, the power of x should be equal to 1. So how many number of variables? For all the variables, the power should be 1. Then only we can say it is a linear equation. So linear algebra basically start with the study of linear equation. How can we solve the linear equation? And from there we will go to vector space and all. So uh, to study the linear equation, one of the main thing we need to study is also matrix. The linear equation we will transform to matrix also, matrix equation. So solving the linear equation and the corresponding matrix equation is same. So to learn about linear algebra, we should know matrix also, because all the operation we will do in matrix and corresponding solution we will take for the linear equations. Now, a linear equation in general is of the form a1 x1 plus a2 x2 plus etc. plus an xn equal to b. Okay, this is the linear equation. Here, whatever we are represented by x1, x2, etc., xn, these are variables. Xi are variables. So, to find a solution of this equation, if the question is to find a solution, what we are doing is to find the value x1, x2, etc., xn, which satisfy the given equation. And here the ai values are scalars. That will be some given values like 2, 3, 1 by 5, like that. And b is also a scalar. So this is what basically is a linear equation. Now, linear equation in two variables. In general, linear equation in two variables, what does it represent? Can anyone tell? For example,
A line.
yeah, it is a line ax plus by equal to c. That means there are two variables x and y, and the equation is in this form. So basically we know this is a equation of a line. Okay. Now we will go to what is system of linear equations. The system of linear equation means we have a number of equations. All are linear. That means we have some equation. Okay, 1 minute. Okay. So what does a system of linear equation mean? So we will write it in a formal way. So we have m equation and the n unknowns. So first one a11 x1 etc. A1 and xn equal to b1. This is one equation. Similarly, we have a21 x1 plus etc. A2 and xn equal to b2 etc. am1 x1 plus etc. amn xn equal to bm. So this is actually a system of linear equation. So what we can say is this is m equations in n unknowns. Okay, you can see there are m equations and the unknowns are x1, x2, etc. xn. Unknown means the variable. Okay. Now, this equation, we can write it in a metric form also. Matrix form also. How we will write? We will take all the coefficient. So, the coefficient of the first equation are a11, a12, etc. a1n. So, that we will write in the first row and the second equation coefficient are in the second row and the last am1 etc. amn. Now, what is the first equation? a11 x1 plus a12 x2 plus etc. a1n xn. So, these two equations, these two represent the same, right? So, what we need the column vector here? Here the column vector should be x1, x2, etc. xn. So, we can see if we are just multiplying these two matrices together, what we should get? The right hand side b1, b2, etc. bm. Correct? So, if you are expanding the matrix, we will get the equation. So, this is the corresponding form of the given system of equation. Now, whatever we are doing for the linear equation, we will do for the matrix and the solution we will find using the matrix and then see it as the solution of the linear equation. Now, before going to more concept, let me just explain the geometry. Okay, before that, any system, any linear system has solution in either, like if we are having any system, its solution can be either a unique solution, that means it has only one solution. Okay, otherwise it has infinite number of solution, or the third case is no solution. So only these three cases will occur for a system of equation. Okay, what is solution means? Solution is a value x1 etc. xn which satisfy all the given m equations. So, what does this means? If we cannot say a system has a finite number of solution. If it has a finite number of solution, say greater than one number of solution, it should have the infinite solution. So these three are the only possibility. Now, when we are considering the systems in two variables, we can see either with the two variables. What we have? a11 x1 plus a12 x2 equal to b1, a21 x1 plus a22 x2 equal to b2. Okay, what does this means? There are two lines. We need to find the value x1 x2 which satisfy both the lines. So what are all the possibilities here? This line can be first case, it can be intersect something like this. Okay, two lines can intersect. So we have only one solution. See, this is the only one solution possible, correct? But we have the possibility parallel lines like this. In that case, we don't have any solution. That means there is no value which satisfy both the line. If it satisfy this line, it will not satisfy this line, correct? And one more thing is infinite number of solution. So infinite number of solution means both the line coincides. Okay, So the first line and the second line are same. So every point in the line is a solution. So in that case, we have infinite number of solution. So we can see we cannot find a system with a finite number n greater than 1 number of solutions. So in the case of three dimension also, we can imagine like that, like two planes intersecting or three planes intersecting. What are all the possible? It can be the intersection can be either line or a plane or uh, just a point, or it can be no point. The solution can be nothing. So these are the basic things about the linear systems. Now we will just recall some concept about the matrices. So we have already seen what is a matrix. Matrix into some column vector equal to another column vector. That is how we have written the linear equation. So as I already told, to solve the linear equation, what we need? We should solve the matrix first. So for that we just need some basic concepts. So I will just revise. So I hope you know matrix addition, multiplication, and scalar multiplication. So I am not okay. Good. Now some properties. Okay. And transpose of A. If any of you doesn't know what does this means, you can ask me. So transpose of A basically means just interchange the row and column of A, and we will denote it by A transpose. And A transpose equal to A. This if this condition is satisfied, if A and A transpose are equal, then it is a symmetric matrix. If A transpose equal to minus A, this is a skew symmetric matrix. Okay. Now matrix multiplication is associative. Okay, what is associative means? If we have three matrices A, B and C, then A into BC equal to AB into C. What this actually means, the order of the multiplication does not matter. First multiplying B with C and then to A. This is same as multiplying AB and then to C. So this is what associative law tells. Now, is the metric multiplication commutative? What does commutative means? AB and BA, whether they are equal or not.
They are not equal.
Not equal. So this is not commutative. Okay. Okay. And one more property about the transpose. We can say AB transpose equal to B transpose, A transpose. And yeah, that's all. So from matrix, I think all of you know how to find the determinant also. So we can just leave as of now. Now again we will come to the linear system of equation. Now already we have a system Ax equal to B. From the linear equation, set of linear equations, what we got is the system Ax equal to B. Okay, so here A is an m by n matrix. So you can just see that system, that is a m equation in n unknowns. So that equation represents the number of rows and unknown represent the number of columns. Okay, so x is a n by 1, that is n unknowns, that is the x vector represent. It is a column, and B, obviously m by n into n by 1, what we will get? M by 1 column vector. Okay, so now in order to find the solution of the system, what we will do is we will take the augmented matrix A, B. So what we will do is we will just write the A, and just to the right of it we will just attack the B also. Okay. Now we will simplify it into a some matrix form, a simplified matrix form. Okay. Using some row operations. We know what are all the row operations. Okay, that we will come to the row operation. Before that, we will simplify the augmented matrix AB to a simplified form, and what are all the solutions of this first matrix is also a solution of this matrix. So that means these two matrices are equivalent. So one solution is another one solution, and this one solution is the other one solutions. So we will do with the simplified matrix. That is our basic concept. Now here what are all the possible row operations? One is interchange of row. If we have two rows, we can just interchange the row. Okay. So whatever the matrix obtaining by this is an equivalent to the previous matrix. And the second one is multiplying a row with a non-zero scalar. So if we have a row, we can multiply with any non-zero scalar, any constant value we can multiply. And the third one is addition of two rows. If we have two rows, we can add these two rows also. So still these two matrices will be equivalent. So combining 2 and 3, what we will get? We can multiply a row and we can add that row to some another row. Okay, that also is possible. So these are the row operation we usually do. So using these row operations, what we will obtain? Row echelon form. Okay, if we have some matrix A, okay, we will do some finite number of the above listed operations. So from that we will, after a finite stage, we will obtain some matrix B. Okay, this B is a row echelon form if it satisfies some condition. Okay, so what are all the conditions? All zero rows should be below the non-zero row. So first we should list the non-zero row top and the zero row should be at the end. Okay, so this is the one condition. Now the next condition is if we have R non-zero rows, okay, the first non-zero entry of some kth row. If I am taking a kth row, some row I am taking. So that entry, okay, maybe I will explain it. So what we are doing is, if it is a matrix, how we will say it is a row echelon form? So all the zero row should be the at the end, and all the first R rows are non-zero rows. Okay, now if it is a 0, the first element is 0, all the entries below, means all the entries in that particular column should be 0. Now if it is starting, the second column is a non-zero entry 1. Okay, then below that there should be no non-zero element. Okay. Now here after this one we can have any element, either 0 or non-zero, anything in that first row. Okay. Okay. Now for the second row, the non-zero entry can be either here, anywhere. Okay. But suppose it is here, then all the zero below, all the element below to this should be 0. Suppose it is 0. Okay. Suppose it is 0, then also it should be 0. But here it is non-zero. Here it is non-zero. So here everything should be 0. Okay. So basically, I think you might have already seen in the lecture video also. So basically its form should be something kind of a triangular kind. So everything here will be some zeros. Okay, here it can be anything. It not exactly in a diagonal. It can be like stepwise also. So while doing some problems, we will go to row echelon form. Okay, so now I think we can see some questions and row echelon form and all. So let us see some questions. Which of the following are in row echelon form? Okay. Is this in row echelon form? Can anyone tell?
Yes, ma'am.
Yes, it is in row echelon form. First the
Yes.
yeah. First the 0 row is below the all the non-zero rows. Now here what we can say, 1 is here, so below that everything is 0. And in the second row the first non-zero entry is 1. Okay, but it is to the right of 1. Okay, if 1 is here, suppose if 1 is here, then it is not in row echelon form. Okay, now second question. Okay, second one, is this in row echelon form?
No.
No. What is the reason? Here,
And first row, first column, last element 1 is there,
yeah,
but below value 0 is not there.
not like that. Okay.
And shape, diagonal.
Yeah. So what we need to tell is, if we have some
Interchange.
matrix, yeah, we can interchange to obtain in a row echelon form. Here the problem is, if sorry, here we have a 1 here. Okay, but if the 1 is here, we can say it is in the row echelon form. So in the first row, we can see the non-zero, first non-zero entry 1 is in the third position. Okay, so in the second row, the non-zero entry cannot be here. Okay, it can be after the third position, but there is no fourth, fifth positions. So but it cannot be in the second position, that is second is before third. So in this form, row echelon form will not be come. And so the next one is 0 1 3 1 0 0 0 3 0 0 0 0. What about C?
Yes, ma'am.
Yeah, it is in row echelon form. Okay, it is yes, this is no. Okay, so why it is in row echelon form? We can say here the in the first row, the first non-zero entry is 1. Okay, the first non-zero entry is 1. Okay, in the second row, the non-zero entry is 3 and it is in the fourth position. So fourth is after the second position. This 1 is in second position and the 3 is in the fourth position. This is okay. Okay, if 3 is, if it is here, still it is in row echelon form. This non-zero entry in the second row can be in the third position, fourth position and so on. But it cannot be in the first position. Okay, and the zero entry is placed at the end, means the last row. Okay, so this is a row echelon form. So we can see this is exactly not in the form of diagonal, maybe a kind of step. Okay, now one more we will see. Two 0 1 0 0 0 and 0 1 0. What about D?
Yes, ma'am.
You check once again. So our condition, one condition is all,
No.
yeah, because there is a 0 row in the second position and in the third row it is a non-zero row. So this should not be a, this is not in a row echelon form, because if there is a 0 row, that row should be at the end. Okay, at the below of all the non-zero row. But here a non-zero row is below a 0 row, so it is not in row echelon form. So that is about row echelon form. Now, why we are adapting this row echelon form? The basic reason for this is it makes the calculation simple. Suppose we have some matrix, some very complicated matrix, that is everywhere we have some entries. Okay, and after some row operations, we are able to obtain it something like this. Okay, in a standard form, the second word will be a kind of row echelon form, we can say. Now, to solve the system of equation, the last one, the one here, this is very easy, okay, to use, because if we are if we have some kind of 1 0 0 0 1 2 0 0 0 and x1 x2 x3 equal to some values, suppose. Okay, now from a very complicated in the set, all the entries are non-zero. From that equation, we have reached into something like this. From this, it is very easy to solve, because from this easily we will get x1 is the value in the right, whatever the value here, x1 equal to that value, and x2 plus x3 equal to some other value. So whatever this value, we will get x2 plus x3. Okay. So the whatever the bigger equation, bigger system of equation, this is equivalent to this equation, system of equation. So instead of solving that complicated one, we can solve this. That is why we are writing the system of equation in a matrix form and then reduce the matrix to very simplest form like this and then solve the simplest form. So whatever the solution we are obtaining, it will be a solution of this simplest form as well as the original one. So that is what we are doing. Now, as we already told, we have various kind of possibilities like unique solution, infinite number of solution and no solution. So when we will get such a kind of solutions, we will see. Suppose our system is Ax equal to B. So we will start with the augmented matrix AB. Okay, and we will do some row operation to obtain some A dash B dash. So instead of Ax equal to B, this Ax equal to B is equivalent to A dash x equal to B dash. So instead of Ax equal to B, we can solve A dash x equal to B dash. So checking the nature of A dash B dash, this matrix A dash B dash, we can say whether it has unique solution or infinite solution or no solution. Okay. Suppose A dash has R because or A dash B dash, anything is fine. So we have the matrix A dash B dash here. So if we are just taking the A dash here and this A dash has R non-zero rows. This A dash is also in a row echelon form. Okay. Suppose it has R non-zero rows. Okay. If R equals n, the number of unknowns. Okay, what I am saying is the number of whatever we are getting at the final. So the number of non-zero rows equal to number of unknowns or number of columns. In that case, we will have a unique solution. Okay. Okay, instead of A dash, I can write A dash B dash here. So one problem here it will come is, now suppose A dash B dash has suppose A dash B dash is 3 rows are non-zero and here it is a 0 row and here it is a non-zero element. Okay. Here this corresponds to A. First part corresponds to A dash and this corresponds to B dash. Okay. In this case, A dash has R non-zero row. So whatever I have written as a line. Okay. That is R non-zero rows. Okay. But if we are considering A dash B dash, it has R plus 1 non-zero row. Okay. In that case, we will have an inconsistent system. What does that mean? The system does not have a solution. So, if A dash B dash is in this form, what we will do? we will write the equation as a dash x equal to b dash. So the equation corresponding to this particular row, it will come 0 x1 plus etc plus 0 xn equal to that non-zero entry. Correct? Sorry, 1 minute. Okay, so corresponding to this row, what we will get a 0, 0, 0 equal to star, that is 0 equal to a non-zero entry. Okay, so this is not possible. This is not possible. Okay, in this case, no solution exists. Okay, now, so what we have seen is a dash, b dash and a dash has different number of non-zero rows, then no solution. Okay, in the row reduced form, if it has different number of non-zero, then it has no solution. And if a dash, b dash and a dash has same number of non-zero, rows, say R. Okay, in that case, R equal to n, then unique solution. And if R less than n, then infinite number of solution. Okay, so for both a dash, b dash and for a dash and a dash, b dash, number of non-zero rows are different, then no solution. If number of non-zero rows are equal and it is also equal to the number of unknowns, that is x1 etc xn, okay, that n, okay, then it has unique solution. If it is strictly less than n, it has infinite number of solution. So these are all the possible cases for a linear system. So now we can do one question. Here we have two equations, 1 minus I x1 minus I x2 equal to 0, 2x1 plus 1 minus I x2 equal to 0. So if this side, RH side is everything is 0, we will call it as a homogeneous system. Okay. And in this case, if we are writing A, okay, if we are writing it as AX equal to B, what we will get? The matrix form is 1 minus I, 2, 1 minus I. Okay. So this is our matrix form, and x1, x2, it is equal to 0, 0. So we told we need to find the row echelon form of the matrix, augmented matrix AB. So in this case, what is AB? 1 minus I, 2, 1 minus I, 0, 0. This is our augmented matrix. But we have one special thing about homogeneous system, that is, if this side is completely 0, instead of finding the augmented matrix AB, we can just do the calculation for the matrix A. Because what we are doing in the operation, either adding rows or multiplying with some scalar, something like that. Okay. So here if we are adding these rows also, for this particular column, nothing, no change will happen. We are adding two zeros or we are multiplying a constant with a 0. So instead of taking the augmented matrix AB, we can just do the calculation for A. Okay. So our A is, we will do this row, we will find the row echelon form of this matrix A. For that, first we can keep the first row itself. Okay, we don't need to change. There is no 0 rows here. So if 0 row is there, first thing is we should take that. We should exchange that row to the last row. Okay. Now what we need is, we kept this 1 minus I just like that. So we need all the element below 1 minus I should be equal to 0. So this 2 should transform to 0. What we can do for that? We can change R2 to okay. First, what we will do? We will change the 2 same as 1 minus I. Okay. Then we will subtract. Then we will get the 0. Okay. Let us see. What we will do is, we will do 1 minus I by 2 R2. Okay. So the second row is multiplied with the constant 1 minus I by 2. What we will do? 2 into 1 minus I by 2. So we will get a 1 minus I. And here also we should do the calculation, that is 1 minus I into 1 minus I by 2. Okay. So you can do the calculation here. So what we will obtain is minus I. So we are obtaining the second row exactly same as the first row. So in the next step, what we can do? We can do R2 minus R1. Okay. So I already told we can do row addition. In the same way, what is this row subtraction means? What we are doing? First we are multiplying R1 with a minus 1 and then adding with R2. So it is basically constant scalar multiplication plus row addition. Okay. So what we will get is 1 minus I 0 0. Okay. So instead of solving the original Ax equal to 0, we can solve this A into x equal to 0. So instead of having two equations, now we are remaining with only one equation. That is the special thing about the row echelon form. So what we can say, 1 minus I 0 0 into x1 x2 equal to 0 0. So this is our reduced form. Now we can say 1 minus I x1 minus I x2 equal to 0. Okay. Now if I am varying x2, according to that I can find an x1. If I am substituting x2 equal to 1, I have one x1 value. If x2 I am substituting I, then I have x1 another value. So depending on x2 I can substitute any scalar. Depending on that, x1 also changes. So we have infinite number of solution. Suppose if I know x2, how x1 will be? x1 will be I x2 by 1 minus I Okay, 1 minus I. So this is the x1 value. So what is the solution? Solutions is the set of all I x2 by 1 minus I. Instead of x1, I am writing the obtained value, which depending on the x2. x2 such that x2 belongs to actually any complex number. x2 can belongs to any complex number. Depending on that, it will change. So all these constitute of the solution space. Okay, these are all the solutions of the given equation. Is this clear, everyone? Is this clear? How we are doing this, Rohit? Okay. Okay, if you have any doubt in between, you can ask. Now, I'll give you a question which is just depending on the matrix. So, if A is a 2 by 1 matrix and B is a 1 by 2 matrix. Okay, A is 2 by 1 and B equal to 1 by 2. Let us C equal to AB. Then a question is true or false. Determinant of C equal to 0. So, we don't know what is the matrix. We only know A is a 2 by 1 matrix and B equal to 1 by 2 matrix. And the statement is determinant of C equal to 0. Where C is the matrix AB multiplied, A and B multiplied. Okay. So, can anyone answer this question? You can just do the calculation for 1 or 2 minutes. Just take some random matrix here, not like examples, in a general format. If A is a 2 by 1 matrix, it will be 2 rows, 1 column. You can give that element as variables. For example, we can take, let A equal to x comma y and B equal to CD. Okay, so and C equal to AB. So it is actually very simple. You can do what is C, like you can find what is C and you can check whether the determinant of C is 0 or not. So just check it quickly and let me know. Any answer?
True.
Yeah, it is true. So this is simple. We can just do the multiplication. How we will do the multiplication AB? A is XY. This is CD. Okay. So what we will get? How we will multiply? We will multiply the first row with the first column and that is our first entry. So first entry is x into C and second entry is first row of the first matrix into second column of the second matrix xd and next is yc and yd. So determinant of C, how we will find the determinant of C? This cross multiplication, this minus this. Okay, that is xcyd minus ycyd. xd. Both are same value, x c by d. Here also x c by d. So it is equal to 0. So the given statement is true statement. Okay. Now the next question is, let a equals so there is one matrix in this form. Okay, and it is given that it is in row echelon form. So the question is, what can be the value of A, B, C, D and E? So what I want is, it need not be, I don't want you to tell exact value, it is 5, it is 10 like that. I just want to know whether it is 0 or non-zero, that is enough. Okay, so just looking at very quickly, I can just read the matrix for you. AC 0 0 0 E 1 D 0 0 0 0 0 A B 0. So this is the matrix. So it is in row echelon form. Can anyone say at least one or one minute? Yeah, there is some problem with the internet. Give me 1 minute. So I'm sharing a new screen. I hope everyone is able to see, right? Okay, if there is some problem, please let me know. So our matrix was 1 minute. Zero E 1 D 0 0 0 0 0 0 Okay. This is our matrix A. So some of you have already answered the question, I think. Okay. Okay. You are saying ABE equal to 0 and C is non-zero. Let us see. So A, B, E 0 and C non-zero. So this is the answer we got here. We will see. Why AB equal to 0? This is the very trivial thing because this one is a 0 row. So below to that it should be. So given that A is in row echelon form. Okay. So below to the 0 row it should be a 0 row. So A and B should be equal to 0. Now why E is 0? Who answered E equal to 0? Can you say why E is 0? Or why C is non-zero? Okay, the answer is correct. You can give the explanation. Okay, I'll explain. So, we got A equal to 0 and B equal to 0. So, the same A is here we have in the first entry also. Correct? So, this is also should be equal to 0. Now, our A is in the form. Let us see, our A is in the form. A is 0. We don't know what is C now. The other two are 0. 0, E, 1, D. And this is a 0. This is a 0 row. Okay. These all are 0 row. Now, we know that this second row, whatever the value of E and D, second row is always non-zero because there is a 1. Okay. Non-zero. So, since second row is a non-zero row, the row above it, that is first row, it cannot be a 0 row. So, we can see the first element, third element, fourth element are 0. So, the only possibility to be non-zero is for C. Okay, if C is also 0, it will be a 0 row. So, this means C should be non-zero. So that is someone has told C is non-zero. So now C is non-zero means the element just below it, everything should be 0. So already all the elements 0, A are 0. So E also should be 0. Correct? E should be equal to 0. Now what about D? Can anyone say D? What can be D? It can be
D non-zero.
D can be anything. If D is 0 also, we won't face any problem, right? Suppose D equal to 0. Now we got C is, here we got C equal to non-zero and E is a 0. Okay. So the first row, it is fine. 0, some non-zero, 0, 0. In the second row, we have 0, 0, 1, D. After 1, whatever the element comes, D can be either 0 or non-zero. It does not going to affect our row echelon form. D can be 0 or non-zero. Okay. So, these are all the possible values for A, B, C, D and E. Is that okay for everyone?
Okay, ma'am.
Yeah, okay. Now, we will see the next question. Okay, I will give some equation. This is very simple. You just want me, I just want you to tell which of the following are linear or non-linear. Okay. So first one is 5x plus 7y minus 8yz equal to 16. So is this linear or not?
Not linear.
Yeah, not linear.
Non-linear.
Yeah, non-linear system because some yz term is coming here, correct? We may think there is no x square term, y square term like this, but not this kind of things, x, y, yz. All this combination also make it non-linear. So it is not linear. Now, x plus y minus 5 square equal to 0. So what about this one?
It is linear.
Linear.
Yeah, it is linear.
Linear.
It is linear. So even though I have written it is as 5 square, again it is just a constant 25. Okay. So the
25.
square term or the product term should not come for the variable terms. For scalar, it can be anything. Like even though we are writing it as a 5 square, it is just a value only. Now, okay, one more. X plus pi y plus ez equals log 5. What about this?
Linear.
Yeah, this is also linear. So some may have confusion
Linear.
like
Because
log.
pi and e are constant.
Yeah, it can be any constant. So wherever, whichever field we are taking, it can be real or complex or anything. Okay, so pi, e are all constant. Log 5 also a constant, not a function here. So this is also a linear equation.
Equation.
Okay, now let us see one more question. Let A is given an n by n matrix and it is given it is A is invertible. So I hope you know what is invertible. Invertible means there exists an inverse for A. A inverse exists or determinant of A is a non-zero value. And
Non-zero.
yeah, given a linear system corresponding to a matrix, we have a some b is there and some unknown x is there, ax equal to b, given a linear system. Okay, so
Ma'am, can you come again? What is invertible?
sorry,
What is invertible?
invertible, do you know determinant of A?
Yeah, yes, ma'am.
Yeah, so if determinant of A is not
Yes,
equal
ma'am.
to 0, then A is
Yes.
invertible.
Yes, ma'am. Okay, ma'am.
Okay, that is the
Thank
one
you.
condition. We will
Yes,
say
ma'am.
this invertibility for only square matrices, and this is one condition. Otherwise, we can say there exists a matrix A inverse such that A inverse into A equals A into A inverse equals the identity matrix. Okay,
Yeah, A inverse into A equal to
A into
A
A
into A is equal to I.
identity.
Right, no,
Okay,
ma'am?
identity matrix,
Yeah,
you know,
yeah.
right? So if such an A inverse exists, then also A is invertible. So both are equivalent
Okay.
condition. If A is invertible, determinant of A non-zero or the existence of A inverse, both are same
Then
conditions
it should
only.
be a square matrix, right, no, ma'am?
Yeah, it is a square matrix. Only for square matrix
Yeah,
we
yeah.
can consider determinant of A. It is defined for
Yeah.
only square matrix. Okay.
Mhm.
Okay. Now
Thank you.
this is a linear system. So we need to check it is true or false. The question is the system is consistent. Do you know what is the meaning of consistent?
System has solution.
Yeah, consistent means system has solution. It can be either unique solution or infinite solution. But if it has a solution, it is consistent. If it has no solution, it is an inconsistent solution. So, what is the answer for this? Whether it is true or false, this statement.
True.
Yeah, this is true. Reason?
Ax equal to B.
Yeah.
B, I mean, A is that is have a linear system, compulsory true. Not equal to means inconsistent, no solution.
No.
No. See, all linear system we can write it as Ax equal to B. Okay.
B form.
But here I am giving.
Ax is equal to B. A is invertible.
Yeah.
If A is invertible, we can write X is equal to A inverse into B.
Yes, we can write. So,
and we can easily find that product A inverse into B.
okay, what we are doing is we are multiplying both the side with the A inverse. A inverse into Ax equals A inverse into B. Correct? What is A inverse into A? This is identity. Identity places element 1. That means if it is multiplied with the x, that is this is Ix. Ix means x only. Okay. So this should be equals A inverse B. Okay. So we got a value A inverse B. Suppose we are substituting this A inverse B to this x here. What we will get? A into A inverse B equal to B. So A inverse B is a solution. Okay. That means there exists a solution for Ax equal to B. This is true only because A is invertible. If A is not invertible, we cannot say anything. We need the matrix and we should check the row echelon form and all the condition that we have already seen. For example, I can say, so I hope this is clear for everyone, right? The solution exists.
Yes, madam.
Yeah, also, actually this solution is a unique solution. See, what we are saying, if it is a solution, it should, see, what we are taking, if A inverse, if X is a solution, it should satisfy. Okay. But A, B are some fixed values. A is a some fixed metric, B is a some fixed matrix. So whenever, like whoever doing A inverse B, we will get only one value X, correct? So that X is a unique value. So we can say it is a unique solution. There are not infinitely many solutions. Now someone was saying Ax equal to B. Since it is equal to B, it has a solution. Let us see. If A is not invertible, what will happen? Suppose A equal to 1, 1, 2, 2 and X is x1, x2, okay, and B equal to 1, 1, okay. Now, what is this? This is actually, if I am writing in terms of equation, x1 plus x2 equal to 1 and 2x1 plus 2x2 is also equal to 1. Okay. So, if I am multiplying this equation with 2, what I will get? 2x1 plus 2x2 equal to 2. Now, this is equation 2. This is equation 1. See, LHS is 2x1 plus 2x2 for both equation 1 and 2. But RHS is different. Since LHS is equals 1 equal to 2. This is not true, right? This is leading to some absurd result. Like, this is not at all true. Why it is happening? It does not have a solution. Okay, we are assuming it has a solution and trying to solve it. So we are getting something wrong. So it does not have a solution. You can see here A is not invertible. So we cannot take the matrix A inverse in front of A to find the solution. Okay, that is how we are why you are using row echelon form and all. If it is invertible, we can easily say the solution exists. Clear? Is there any doubt in this? Yeah, sorry, there was some internet issue. Okay, is there any doubt till now? If you have any doubt, you ask, and yeah.
No.
Okay, then let us go to next problem. So this is an easy question. For what value u equals 3 to 1b will be a solution of the equation x1 plus 2x2 minus 4x3 plus 3x4 equal to 15. Okay, is the question clear for everyone? We are asking u
Yes.
3 to 1b is given. B is some unknown value, we don't know. So we need to find what is the value of b for which this u is a solution of this one. That is, you should satisfy this equation. What should we
4
do?
by 3. 4 by 3.
4 by 3. So we should it is not 4 by 3, I think. Okay. We should substitute this value to here. See, actually what is 3? X1 is 3. It is given instead of x1, x2, x3, x4, it is given 3 to 1b. It is a solution. Okay. So x1 is 3, x2 is 2, x3 is 1 and x4 is b. Okay, so we substitute these values in this equation. So what we will get? 3 plus 4 minus 4 plus 3 into b. This only we don't know. This is equal to 15. Okay, so to find b, what we have? 3b equal to 15 minus 3, which is 12, and b equal to 4. Okay, so the only possibility for b is 4, so that this u is a solution of the given linear equation. Clear?
Yes, ma'am.
Okay. So the next question. So we will consider a system of equation. X plus ay equal to 4 and ax plus 9y equal to b. Okay, a, b are some unknown value, we don't know. So we will see what are the questions here. Question for what value of a. So the value of a we need to determine such that the system has unique solution. So this is the first question. So see, this is our system. Okay, while I am writing these questions, maybe you can just write the augmented matrix and reduce it to row echelon form and find the value of a and b for which, or find the value of a for which the system has unique solution. You can do in between. Okay, I will write the second question also. Okay, so this is the second question. Find the pairs of value a, b. That is, we need to find the value of a and b such that the system has more than one solution. Okay, so if we are getting such a system, what we will do first? We will just write the row echelon form of the, like we will
Yeah,
write the
maintain.
matrix form and then row echelon form. Okay, so what is the matrix form here? 1 a 9 into xy.
Yes, equal to 4 and
Yeah, 4 and b. This is our matrix form, equation in the matrix form. Now we will write the augmented matrix from here. Augmented matrix means we will take a and b together. Okay, so that is our 1 a 9 4 b. We will attach this to the a. Okay, now we need to solve the, sorry, we need, this is equivalent, we need to find the row echelon form. For that we will keep the first row like that. So what operation we should do for the second row? R2 should change to R2 minus a R1. Okay, we need to make this entry as 0. So a minus a is 0. Correct? So we should take R2 minus AR1. So this is 0. Now the same should be applied for all the elements in this second row. So this is second element in the second row will come 9 minus a times a. Okay, that is 9 minus a square. And here it will come b minus 4a. Clear? So I am just reducing it into a simpler form. So the first question is, for what value of a the system has unique solution? Can anyone say? When will the system has unique solution? Like for what value of a? Just leave about b now. Any answer? So this is actually, as I told, this is the A matrix. Okay, A dash matrix and B dash matrix. Okay. Now, if the number of non-zero rows, see, if the number of non-zero rows is equals number of unknowns. Okay, in that case, what we have? Unique solution. Correct? See, suppose 9 minus a square equal to 0. That is a equal to plus or minus 3. So what we will get? We will get the matrix as 1, a, 0, 0, 4, b minus 4a. Okay, something like this we will get it. Actually, in this case, if b minus 4a is also non-zero, suppose b minus 4a is non-zero, then what can you say about the system? Is there any solution for the system? See,
The entire row will become 0. So
So see the
No
second row.
solution.
Yeah, second row. The second row is coming as
It will
0
be
x
non-zero row.
0x1 plus 0x2 equal to b minus 4a. And we know b minus 4a is not equal to 0. But this is equal to 0. This actually leads to some contradiction, right? Okay. So if a equal to plus or minus 3, okay, and b minus 4a, b minus 4a actually depends on b also. We don't know what is the value of b. If it is not equal to 0, the system is inconsistent. No solution. Okay, but the question is to find when will it have a unique solution, and the next case is when it will have an infinite number of solution. So it should not be equal to a not equal to plus or minus 3. Correct? What was our 1 a 0 9 minus a square 4 b minus 4a. If a equal to plus or minus 3, this is becoming 0 and we are getting some inconsistent one. Okay, so it should not be equal to 0. Okay, to get a unique solution, see why we are saying it should not. What is our equation now? X1 plus ax2 equal to 4 and 0x1 plus 9 minus a square. This is a non-zero value, correct? X2 equal to b minus 4a. Since 9 minus a square is non-zero value, we can say x2 equal to b minus 4a by 9 minus a square. Otherwise, this division is not possible. Okay, that is why we are saying 9 minus a square should not be equal to 0. That is, a should not be equal to plus or minus 3. So, if it is non-zero, we will get the value of x2. This value we can substitute in this equation, and to obtain the value of x1 equal to, we will obtain a value. So in that case, we will get a unique solution. Okay, also this case is number of non-zero row is 2, correct? Non-zero row equal to 2, which is equal to number of unknowns. So this is the condition we already told to have a unique solution. So in order to have the two non-zero row, we want 9 minus a square not equal to 0 or a not equal to plus or minus 3. Okay, this answers. In this case, we have unique solution. This is the value of a. Is that okay for everyone? Any doubt in this?
Ma'am, can you come again, please?
Okay.
After augmented form, we have done Rollemetric form.
So first we are starting with the augmented form and some row echelon form we are reaching. Okay. Now our condition to have a unique solution
Yes.
is non-zero rows. Number of non-zero row should be equal to number of unknowns. Okay.
Yes.
Here the number of unknowns is 2. Correct?
Yes.
X and Y. Okay. So number of non-zero rows should be equal to 2. Then only we will have a unique solution. Okay. So here we know this is a non-zero row because 1 is there. So whatever the value of a, this is a non-zero row. But second one, to have a non-zero row, it should be equal to,
It should not be become 0. Yeah.
yeah, so it should be equal to non-zero. Okay, that is why we are taking a should not be equal to plus or minus 3. Now, one more thing what I was saying here is, suppose you can ask me, this is a non-zero row. If it becomes 0, okay, still we have one more element. We can keep it as non-zero and still we have two non-zero row, right? That is why the problem arises. If we are keeping like this is not a part of A actually. This is the other side B. Okay, we need to check for A, the number of non-zero rows of A. Okay, so if it is 0, for A we have number of non-zero row only 1. So it should not be equal to 0. Now if it is 0 and it is non-zero, we are getting that inconsistency. That means one side 0, other side see
We have
like
one
this.
number. Let's
Yeah,
fix it.
one side is 0 and the other side is non-zero, we are getting. Okay.
Yes.
Now, when we'll have it, the next question is find those pairs A and B for which a system has more than one solution. Now, in this case, we already told for unique solution, number of non-zero row should be equal to the number of unknowns. Okay, for
Nice.
number of non-zero rows is equal to number of unknowns was the condition for unique. But if it is strictly less than, okay, if it is strictly less than, we will get infinite number of solution. Okay,
Yes, ma'am.
so already we told here it is 0 and here it is non-zero, means inconsistent. So we need the number of non-zero rows strictly less than number of unknowns. Number of unknowns is 2. So number of non-zero row should be 1, right? So the number strictly less than 2 is only 1. Okay. And the first row should be non-zero and the second row should be the 0 row.
Here.
Okay. So what we want is 9 minus a square equal to 0, b minus 4a equal to 0. Both these conditions should satisfy. Okay. So for having infinite solution, what we need? Number of non-zero row should be strictly less than number of unknowns. Here it is 2. Okay. So this should be equal to 1. So the second row should be equal to 0. Should be 0. So in second row, we have two values, 9 minus a square. It should be equal to 0 and b minus 4. It should be equal to 0. So from here we will get a equal to plus or minus 3. Now if a equal to 3, we will get b equal to 4a, which is equal to 12. And if a equal to minus 3, b equal to minus 12. Correct? Okay.
Yes, ma'am.
So the case when AB equals 312 or AB equal to minus 3 minus 12. Okay. In both of this case, we have infinite solution. See, B depends on A. We cannot write 3 and minus 12. 3, 12 and minus 3 minus 12. When we are substituting 3, we are getting 12. So it should be 3, 12 and minus 3 minus 12. In this case, infinite solutions are there. Clear?
Yes, ma'am.
Okay. Okay, we will do a similar kind of question, one more question. So actually this kind of questions are there in your assignment, graded assignment also. Not exactly same, but the similar question. So it will help you in solving that. So given a system and it is given that it has a unique solution. So the question is, what is K? This is our question. So what we will write? As usual, we will write the augmented matrix first, 5K, 5. And we will reduce it to the row echelon form, 1 to 1. So what we should do here? We should change R2 to R2 minus 5R1. So what we need is in row echelon form, if 1 is there, below that it should be 0. So to make 5 0, what we are doing? 5 minus 5 times 1. Okay. So that we will do here also. K minus 10
K minus 10,
and 0. Okay.
0.
So again, it is given it has a unique solution. So what can be the value of K?
10.
Not equal to 10.
K
Yeah.
not
K is
equal
not
to
equal
10.
to 10.
Yes, K not equal
K
to
is not equal to
K
10.
not equal to 10. Then only we will get 2 non-zero row, which is same as 2 unknowns. Okay. But if K equal to 10, we will get infinite number of solutions.
Infinite.
Okay. Now that also we can see. If K equal to 10, what we will get? This is equal to 0. Correct? So we have only one equation. X plus 2y equal to 1. This actually represents some lines, right? Some lines in the plane. That line has many points. So all the points are solution of this equation. So there are infinitely many solutions. That is what we are saying, the infinite number. Okay? Is that okay?
Yes, ma'am.
Okay. Now we will see some statements. We need to check which of the following are true or false. If Ax equal to 0, x equal to 0 is a solution. Okay, so what about this? Yeah, you can tell now only. Is this statement true or false? A system is given a matrix into x, which is equal to 0. So the statement is x equal to 0 is a solution of this system. Yeah, this is obviously true. If we are substituting 0 here, we will get
Yes.
this is satisfied. So it is true. Now the second question is, if Ax equal to c with c not equal to 0, then x equal to 0 is a solution. What about this one? Same, we have a system Ax equal to
False.
c. False. Because if we are substituting 0 here, we will get 0
Yeah.
in the LHS and non-zero. C is non-zero in the RHS. So it is obviously false.
False.
Okay. So one thing here we should note is, if the instead of B here, that means in the right hand side, if it is 0, that is as I already told, that kind of system is called a homogeneous system. Okay. In that case, always we will have a solution which is the trivial solution 0. Okay. But in this Ax equal to c with c non-zero, in this case only we need to check whether it has a like inconsistent, consistent or not, because in this case it is always consistent because it has a solution. In this case we don't know, it can have or not. Now the next statement is, if Ax equal to 0 and x1 x2 are solutions and c is a constant, so cx1 plus x2 is a solution. So what about this statement? If two solutions are given, x1 x2, I am multiplying with c and then adding c x1 plus x2. C is a constant. It is a solution. Is this true or false?
C is multiplied to x1 only.
Yeah, c is multiplied to x1 only. how we will check it is a solution or not? We can substitute in the given equation.
If it satisfy equation.
Yeah, if it is satisfied, it is a solution, otherwise it is not. Here that is what happened in the second case. It does not satisfy. What about this one? Okay, this is just a property of our matrix. A is a matrix, right? So A Cx1 plus Cx2. What we can write? Actually, if we have like this, we can write it as A into Cx1 plus A into x2. So yeah, maybe later on you will learn about linearity and means linear transformation and all. So just you can, for any matrix you can do this. Okay. Some matrix A into B plus C is there, means it is equal AB plus AC. Okay. Now again we can do C into AX1 plus AX2. Now what is this value?
C into 0.
C into 0, because x1 is a solution of this. So AX1 equal to 0, correct?
Plus
And x2 is a solution of
0.
this. So this is equal to 0. So this is 0.
0.
So it is a true statement, correct?
Yes.
Now, next again I am, here it was Ax equal to 0. Now Ax equal to some C, C is a non-zero value. Okay. Again x1, x2 are solution, and suppose k is a constant. K is a constant value. Okay. Now the same question I am asking. In this case, kx1 plus x2 is a solution. So we need to check whether it is true or false. The same way you can substitute it in there. You can check any idea? We can see.
True.
Okay, we can see. What we are doing, instead of x we are substituting. Okay, if it is equal to C, it is a solution. So let us see, as I already told, we can split it as k into ax1 plus x2. Sorry,
AX2.
ax2. Okay, so this is ax1 equal to
Into C.
C, correct?
C.
Because x1 is a solution of this ax equal to C, and x2 is a solution. So ax1 equal to C and ax2 equal to C. Okay. So this is equal to C and ax2 equal to C. So we are getting C
K
into,
plus 1 into C.
okay. But if it is equal to C, then only we can say it is a solution.
That is the
Kx1 plus
solution.
x2. Okay. So in general, it
How
is,
we are writing C into C plus C?
sorry, which one?
Because x1 and x2 are solutions.
Yeah.
So that will become 0, no?
No. What is the system here?
No.
Ax equal to C.
Okay.
So x1 is
Okay,
a
okay.
solution of this system, means Ax1 equal to C. X1 satisfy this equation, not 0. And Ax2 equal to C. C is some column vector. Okay. A is a matrix, x1 is a column, C is a column. Is that okay? So
Yes, ma'am.
that is why it is coming C here. So in general, for some particular values of k, it may satisfy, but in general it is not true. So I will Okay, you can just find it as a homework. Find A, C, x1, x2, k such that above statement is false. In general, if a statement is true, we will prove that. Okay. If it is false, we should give a counter example. That is proper counter example that it is not a solution. That means some value cx1 plus kx1 plus x2 does not satisfy this. So I want you to find some matrix A C such that Ax equal to C and some solution x1 x2 of that one such that kx1 plus x2 is not a solution. So just try to find such a values for this. Okay, just try it. It is a
Yes.
it will be very easy.
Yes, we will try.
Yeah, good. Now the question is, find a linear equation whose solution consists of 1, 2 and 2, 3. Okay, that means we need to find some system ax plus by, something like that. Ax plus by equal to c, such that this 1, 2 and 2, 3 are solution of that not system, a linear equation. One equation. Okay.
Linear equation.
Yeah. So one thing is we can just consider ax plus by equal to c. Okay, we need to find this equation means we need to find value of a, b, c and all such that 1, 2 and 2, 3 are solution. So what we can do, we will substitute 1, 2 and 2, 3 here. Okay, what we will get, a plus 2b equal to c and 2, 3 is a solution means 2a, see x and y are variable, a, b are constant. Now what we want to find is what is this constants. Okay, we need to find the linear equation. So this is 2a plus 3b equal to c. Clear? Now we will obtain, if we are doing 2 minus 1, what we will get, a plus b equal to 0 or a equal to minus b. Okay, now if we are substituting this to 1, we need to find the value of a, b and c. Okay, if we are substituting this, what we will get, a plus 2, instead of b I can substitute minus a equal to c. Okay, that implies c should be equal to minus a. Okay, so if I am fixing a, suppose a I am taking as 2, then b should be minus 2 and c should be minus 2. Now let me write this value here. A is 2, so 2x minus 2y equal to minus 2. This is the equation I obtained. Okay, now instead of 2 we can choose any value, 1, 5, 2 by 3, anything we can choose. Okay, now let us just check whether this equation satisfies the two given value. Okay, so first one is 1, 2. First point is 1, 2. We will substitute 2 into 1 minus 2 into 2. That is 2 minus 4 equal to minus 2, correct. Next value is 2, 3. 2, 3. That means 4 minus 6 equal to minus 2. Okay. So this equation satisfies. So we found a linear equation whose solution consists of 1, 2 and 2, 3. Okay, this is the arithmetical way of finding or arithmetical way of finding. Okay, can anyone think about any other way of finding the linear equation other than just writing this equation, finding solution and all? What will be the what actually the equation represents in geometrically? What exactly this represents?
That points 1, 2 and 2, 3 will be point of intersection of the straight line.
Yeah, of the straight line. So this equation actually not point of intersection. These two are in the straight line.
That will lies on one straight line.
Yeah, in one straight line. So if we are asked to find a linear equation whose solution consists of 1, 2 and 2, 3, what we actually doing is we are finding the straight line which passes through this 1, 2 and 2, 3. Correct? That is what we exactly doing geometrically. Okay. So we have 1, 2 here and 2, 3 here. Okay. So a linear equation satisfying these 2 points means it should be a straight line passing through these 2 points. Correct?
2 points.
So instead of finding all this, we can just find what exactly the straight line passing through this point. So what is this? What we this is
y
points.
minus y1 upon y2 minus y1.
Yeah. So if we are taking this as the first coordinate, y minus 2 by x minus 1 should be equal to 3 minus 2, 2 minus 1. Correct? So y minus 2 should be equal to x minus 1 or y minus x equals 1. Correct? And from here what we obtained, 2x minus 2y equal to minus 2. Okay, can you relate these two equations? These are actually same, right? This is just a constant multiple of the first equation. If we are doing minus 2 into y minus x minus 2 into 1, I am multiplying with the minus 2 both sides. What I will get? 2x minus 2y equal to minus 2. Okay, that is the equation we obtained earlier. So the earlier one covers all the like constant multiples also. That is the only difference. If we are just finding a linear equation as a straight line, then we are getting the simplified form of the straight line. This also we can simplify by dividing throughout by 2. Correct? So this is how we can obtain the linear equation. Is that fine for everyone?
Yes, madam.
Okay. Okay, now some questions regarding some matrices. So the question is,
Ma'am, 1 second, ma'am.
yeah,
Ma'am, here you have done no minus 2 into y minus x equal to minus 2 into 1, no? In which method you get? What step is that?
here I am just multiplying both sides of the equation with the minus 2. I have some
Yeah,
x
minus
equal
2
to y.
into-
Okay. So, if
So we are
x,
getting the first equation. Yeah.
yeah, we are obtaining this equation. So what I want to
Yes.
say basically is these two are same. Just
Yes, ma'am.
multiplying by a constant, we are obtaining one from another. Correct?
Yes, ma'am. Yes, ma'am.
Okay. So this is basically the same equation, even though we are obtaining in different way.
Yes.
Okay.
Yes.
So the next question is, if A and B are some 2 by 2 square matrix, then which of the following are true? If a square equals I, a equal to I, or a equal to minus I. Okay, I will write two more statements. By that time you can try to solve the first statement. Like you need to check whether it is true or false. If it is true, prove it. If it is false, give a counter example. That means a counter example which does not satisfy this statement. Okay. Anyone got first one?
Yes, trying.
Okay, just try it. We are not giving any condition for A and B like invertible or anything. It is just some 2 by 2 matrices.
True, first true.
First true. So do you have proof how you have obtained?
Basically, A into B is if A into B is equal to I, which means if B is equal to A, then both are inverse. Then
No, I am not
um,
like it is invertible or not. That condition is not here. It can be invertible, it cannot be. That we don't know.
so, but if A square, I'm assuming that if A square we can write as A into A, where one is A, second can become B, right? So, and if AB is equal to identity matrix, then both has to be identity matrix.
Okay, we may think like that it has to be I or minus I. Actually it is false. Okay. First thing, actually it is invertible. No need to think about that because a square equal to I and determinant of a square equal to determinant of I. Okay. So actually determinant of I is non-zero. That means determinant of a square we can write determinant of a whole square. This is non-zero means determinant of a should be non-zero. So
Non-zero.
actually, but invertibility does not play a role here. This is just a matter of giving a counter example. So no need to worry if you are not getting a counter example because this is just like if we are too much dealing with matrices equation and or we will be able to do. So I will give you one example. It is just an arrangement. Okay. Instead of writing I, we have 1 0 0 1. Instead of that I am just doing that transpose thing. Okay, this
Right.
is my A, so 0 1 1 0. So if I am multiplying this row with this column, correct? So what is the value? First entry is 1, then the next entry is 0, next is 0, and next is 1.
One.
And we got identity, but this is not identity. A is not identity, correct? So this is a
Yes.
counter example. So 1 is false. Now, can you think about this one? If a square equal to 0, then a equal to 0. Okay, this is a false statement. Just think about any counter examples. It is not true. It is false only, that I can say now. If any of you can, just think sometime and find a counter example. here A cannot be invertible. As earlier, here what will be determinant of A square is determinant of 0. It is 0. So determinant of A is 0. So here A is not invertible. So don't try with invertible matrices. Just try with some non-invertible matrices. So that non-invertible means one row can be completely 0. The other one is not 0. Something like that.
-1 to cross two matrix.
1 1 minus 1 minus 1. Okay. Let me check. I'm not sure this. So what we will get is 1 minus 1 0. 1 minus 1 0. 0. Okay, this is correct. Okay, just check the calculation again. Okay, if it this is A square is 0, but it is not a 0 matrix. Or one simplest example I can give is 0 1 0 0. Okay, this is the very simplest example. This is 0 0 0 0. Correct? Okay, so this is also correct. This is also correct. Anything is fine. Just thing is you need to give a counter example. Okay. Now, what about third one? If A plus B equal to 0, A equal to minus B. True or false?
True.
Yeah, it is true.
True, ma'am.
There is nothing in this actually. What we are doing is like just taking the B out, B to the right side. That's all.
Right.
Like
Right.
yeah, just like usual equation with the matrix also, we can do all these kind of operations. This addition, this and all. Okay. So yeah, it's 8. I think we can stop here today, and we will meet in the next week. So let me, okay, before that, any doubt till now in any of the question?
Not.
Okay, it's okay for everyone.
Thank you, madam.
Ma'am, you told no that AX equal to C, then C not equal to 0, X and X2 equal to solution, K is an...
Yes.
That I didn't get it properly.
Okay, okay. I can tell you again. So it is given AX equal to C. C is a non-zero.
C plus C.
Sorry.
Yes, ma'am.
And X1.
Yeah, at last we came to
okay, last only. C is a scalar. So these are solution means first we will write AX1 equal to C, AX2 equal to C. So solution means this equation is satisfied. When we substitute instead of X the X1, we will get this equation, means that equality is satisfied. Okay. Now our question is, okay, let us take it as K scalar. Now what about Kx1 plus X2? If it also satisfies, this is equal to C. Okay. If it is satisfied, it is a solution. If it is not satisfied, it is not a solution. Okay, correct? Now, we will do A into Kx1 plus X2. In matrix, we can do this kind of operation. Okay, maybe after 1 or 2 weeks, you will be very clear about why we are doing all this operation. So in usual matrix also, it is fine. So K into AX1 plus AX2. Okay. Now, since AX1 is a solution, we have AX1 equal to C here, right? And AX2 equal to C. Now we are substituting. See, C is a vector actually. See, A is a matrix, X is a column vector, C is a column vector. So K into C plus C. K is a scalar.
Yes.
Okay. So what we will get? K plus 1 into C. Okay. For example, suppose I am taking the scalar K equal to 2. The what is this? This is 2c, right?
Yes, ma'am.
So what we need, if it is a solution, a into kx1 plus x2 should be equal to c. But we are getting a into kx1 plus x2 equal to 2c or some k plus 1c.
Yes.
Correct? That means it
Yes.
is not a solution. If it is a solution, it should satisfy this.
Okay. We should get only C.
Yeah, we should get only c. That's why I told you to find some matrix A. Okay, find a matrix A and such that x equal to, find a matrix A and C, find two solution x1 and x2 of this. But kx1 plus x2 is not a solution. Try with the sum matrix. Okay.
Yes, ma'am.
If it is not
Yes,
working
ma'am.
with the sum matrix, try with another. If you are first trying with some invertible matrix, then if it is not working there, try with a non-invertible matrix. Okay. Try with some symbol matrix, and if you are trying with some example, you will be able to understand why it is not coming. Okay. Just try.
Okay,
If you
ma'am.
still have doubt, we can see in the next week, like this kind of example, counter example I can give in the next week. Okay.
Yes,
If
ma'am.
you are not able
Yes.
to get.
Yes, ma'am. Thank you so much, ma'am.
Okay. So any other doubt? Okay. So if there is no other doubt, we can stop the meeting for today. We will meet in the next week.
Thank you, ma'am.
Yeah. Okay. Yeah, we will meet in the next week. Same time.
Thank you,
Tuesday.
ma'am.
Yeah. Thank you everyone for attending. We will see next week. Bye.
Thank you, ma'am.
Thank you, ma'am.
Okay. I will close the meeting now.
Yes, ma'am.